I want to ask you to grab your graphing calculator real quick. Some of you may not have done this before. You may not have used the graphing part of this, but it's coming back for this particular question. So I want you to go to y equals and go to y equals and make sure that every single one of these y's is cleared. So you press the clear button and make sure everything is wiped out. Okay, so if you press y equals and then make sure everything is cleared, and on top of that, make sure that all the plots on the top here, if you go all the way to the top, they should not be highlighted. So if it's highlighted, if it's like this, for example, if it's solid highlight, you go to it and hit enter to make sure that there is nothing highlighted. Okay, it's important that you know that that is the case right now. We'll do more of that. If you joined us and you didn't do applied before, we'll guide you through it. Okay. So I want you to just do a simple exercise with me. Let's go. We're gonna type in 2x. The variable x is right up here where I'm gonna use a highlighter here. Right here. See my green highlighter? That's the letter x. So 2x squared. So we're gonna square that. Okay. Plus 5x minus 3. Let's do something like that. 2x squared plus 5x minus 3. I'm going to give you a crash course right now, but what do we call something when there's an x squared? We call those quadratic functions, and the graph ends up being starts with a P. Oh, okay. You were listening last year. So hit graph. Oh, and I see this. Yours might look different. So let's all look at the same thing, shall we? You remember how to do that? How to get the same window for everybody? Zoom, and then zoom standard. Or just press 6. It does the same thing. Now we should all be looking at the same thing, right? Let me just try something here. There we go. That's a little better. So in this particular section, I'm using quadratics again. So we're going to try to find, what do we call the points where it crosses the x-axis again? The x-intercepts. Those are going to be important for us. So here we go. How do you find the x-intercepts? I'm going to write that down in your notes in a bit, but you go y equals. You make the second line we're going to graph equal to 0. You hit graph. And now we have two lines. One is right along the x-axis, and this is the parabola we're graphing. So to find the x-intercepts, we go second, trace, and then we use intersect. That is the function we're going to use. And I will do this again later. So if you're right now like, I don't remember this, just follow me. And so what you do is, when you're on the first curve, you go with the cursor as close as possible to that intersection. And then you just press enter 3 times. Enter, enter, enter. Until you see intersection, and it will tell you exactly where that parabola crosses the x-axis. You want to do this one more time. Second, trace, fifth option. Now we're going to go over to the other side, right? And hit enter, enter, enter. And that's our second x-intercept. And you will see in a bit why that is important to us. Okay? So for now, that was just a little crash course on finding x-intercepts. Grab your booklets. Go with me to page 14. And I know some of you are from pre-cal. You joined us from pre-cal, so you will be able to factor. If you like to factor, that is also going to be an option. Okay? It happens every year. I have some pre-cal folks in here. Welcome, by the way. We should have more people joining us, joining the bright side, right? Solving factorial equations. Okay, so now we're not going to do expressions. It's going to be equations, right? Means you have to figure out what the possible values will solve the equation. Okay, You will recognize this when you see factorial expression equals an expression on the other side. Could just be a number. Okay. These are the steps you do just as before, page 14. State the restrictions. I actually got this right on this one, right? Pick the largest one. And so state the restrictions, simplify the factorial, expand whatever is left to distribute or FOIL. We've done that until now, guys. This is new. Bring everything over to one side so that the other side is equal to 0. This is new, right? This step right here. And then you will have a number of ways of solving it. If there's an n squared, you'll have two answers. It'll be a quadratic. Factor or use the calculator, it's up to you. If only n is left, there's only one answer. And I ask you to verify your answers, plug answers into the original equation, and check that left-hand side is equal to right side. If so, the answer is correct. Watch this. Just for you guys here, using the calculator, we let y2 equal to 0, and then we go second, trace, intersect. Okay, second, trace, intersect. That's how you use the calculator to find the X-intercepts. And some of you know what I'm talking about, and you'll actually prefer using the calculator. Some of you want to factor. That's fine. You'll see what I'm talking about in a bit. So these steps are just me. They're not textbook, okay? So anyways, let's start here. So let's start with our restrictions. N is greater than 0 at the top. N is greater than or equal to 2 at the bottom. This is my greater overall restriction, okay? Let me just go up a bit here so you guys can see. Okay, overall restriction. Okay. So let's work. You work with this side first. Okay. Simplify this factorial as much as possible. So I'm going to go over on this side. I'm going to go n times n minus 1 times n minus 2. I'm expanding the greater of the two expressions in such a way as to cancel out the factorial. So you do not want any factorials left. Okay? So notice the equation there, the equal sign, meaning you will have an answer for n. There will be an answer. Okay? Then you distribute, right? So that's, let me use my highlighters here. Right? And so you end up with n squared minus n equals 90. I picked a nice and easy one to get us going, okay? And then what does it say next? Bring everything over to one side. So basically you want 0 on one side. So I'm going to bring the 90 over to this side. So it's going to be n squared minus n, and the 90 comes over subtracting, right? And you're left with 0. Okay. And then once you get to that point, okay, note n squared, right, means 2 possible solutions. Okay. What did I say? What did I say there? 2 solutions or 2 possible solutions? I said 2 possible solutions. Keep that in mind. Okay. And so what we will do is we will find X-intercepts, okay, of parabola. So basically, y1, you enter n squared minus n minus 90, and y2, you make it equal to 0. And then we're going to go second, trace, 5, which is intersect. Why is he doing that so many times? Well, this is part of showing your work, right? And so let's go ahead and do that. Let's go ahead and grab our calculator. You need to follow me, right? Join me for the ride. Okay? And we go to y equals, clear whatever is in y1. I'm leaving y2 equal to 0 in this case. So the ends, that's the variable that this question is using. I'm still going to use the x variable on my calculator. Sorry, I'm going to move over to this side. So you just type in x, right? X squared minus x minus 90. That's how you type that in. And then once you have that figured out, you hit graph. And this is a bit of a problem. This is where if you were in pre-cal last year and you haven't used this, you're going to have to kind of like maybe ask me some questions as I do this. What do you notice here? It's a little bit of a small window, right? So you need to adjust these parameters. And there's a button called window. So press it with me. And because we press standard zoom, the standard zoom is -1010 for your x-axis, -1010 for the y-axis. Just focus on x-min, x-max, y-min, y-max. That's all you focus on in this course. So we're going to do this. I'm going to go to my y-min and I'm going to go -20. Not minus, guys. Watch. Do not use this one. When you enter a negative value, you use this one, or else the calculator will complain. As soon as you try to graph, it will say, can't do it, syntax error, okay? So -20 to 20 for the x-axis. That's all I'm going to change. So you're just expanding a little bit on either side, and then hit graph. Once you have those values, window, right? I pressed window to get me to here. Then I go graph, and there you see both x-intercepts. I know you would like to see a little bit more here, right? We can tell that the parabola goes here. So why don't we go and look at that? So your window, we're going to go y-min. I'm going to go -30. I'm going to try that. You got to try it sometimes. Oh, still I need to go even lower. So I'm going to go y-min. I'm going to go -80. Hit graph. Oh my goodness. I do this on purpose, by the way, because this is what a lot of students experience, right? So there it is. There you see, what do we call that point again? Anybody remember? Vertex up there. Yeah, all of you remember. I know it. You were thinking of it all summer, right? Anyways, let's focus on the x-intercepts. So second trace 5. If your cursor is on the screen, you're laughing, right? It's good. But sometimes, watch what I'm going to do. Sometimes the cursor is going to be way, way away. So I'm pressing left and it's just disappearing and it's way up there. Look at the y values. So you have to read this. I'm going right and I notice that it's coming down. So I'm coming down. There it is. It showed up. So I hit enter, enter, enter. So the first one, write it down. N is equal to -9. That's my first solution. Okay, that's solution number 1. Solution, SOLN, that's how I do it to shorten it. Solution number 1 is n is equal to -9. Then I go second trace 5 again, and I'm going to go over to the other side, arrow sideways. Just keep holding it. That's close enough. Enter, enter, enter. And so that's 10. So solution number 2 would be n is equal to 10. That's it. I know some of you are like, stay with me, guys. I'm going to walk you through it. So you've got 2 solutions. You got to go by your restriction. What does my restriction say? N has to be greater than or equal to 2, right? That is a fact. So this one obviously doesn't cut it. So this one is extraneous. We call that extraneous, not applicable. Okay, so this one we cannot use. You don't have to remember that word, but that's what we call it. This is your solution here. Okay, so we're going to check. Don't just blindly trust your answer. Go back to the original, which calls for n factorial over n minus 2 factorial is equal to 90. That's what the original says. You plug in 10 for n. So it's 10 factorial over 8 factorial. That's supposed to be equal to 90. You can expand. You can do whatever you want. You can use your calculator at this point. So I'm going to go 10. Okay, math, probability. 10 factorial divided by 8 factorial. If it doesn't work, you have to expand, right? And math. Anybody come up with a shortcut? So that's 90. Okay, so left-hand side equals right-hand side. It's correct. Yeah. Oh, because it's n minus 2. It's right. N is equal. My solution says n is equal to 10. So I plug in 10 here, and this is 10 minus 2, which is 8. Make sense? Yeah. We're good? Factorial equations, guys. Can't get better than that. Cannot get better than that. Let's go to the back side and try some uglier ones. I'm going to leave that one to you. Kind of scared to give you the answer because so Dirksen, what are you up to? N is equal to the solution. This solution here, n is equal to -1. You're going to get another one, but n is equal to -6 is going to be the other one, but this one doesn't go. This one will work, right? So I'm going to leave that one up to you to try that one. You're going to have to use the quadratic. You're going to have to graph and figure out. Yeah. Yeah. Good question. Good question. The reason is basically always go back to your original restriction here. We identified right at the beginning that n, for this thing to work, for this thing to not be undefined, we needed this to happen. N has to be greater than or equal to 2. So out of these two answers, this is not greater than or equal to 2, right? So then we can't use it. This would not be applicable. It has to be this, right? So always go back to your restriction. Sometimes they both qualify. Sometimes none of them qualifies, actually. But there could be two possible solutions. In this case, there was one. Does that make sense? So go back to your restriction, which you identify right at the beginning. Keep asking. That's good. I'm going to do this one because something like this showed up on a provincial exam once, and it threw everybody off because we hadn't done this stuff, right? But there's really just a little twist to it. Watch this. Usually, you have all the factorials on one side and a number on the other side. So what you do here is this. Am I going to use a different color? I'm going to use red here real quick. Just to make, what you do is you just, real quick, you go n plus 1, you divide both sides by n plus 1 factorial. And that gets rid of this. Okay? And then you end up with, I'm going to do that here, n plus 2 factorial over n plus 1 factorial. And on the other side, you're left with 20, correct? And so you just had to like massage it a little bit, and then it looks like what you're used to. So if I ever do that to you, just move stuff over, divide both sides, or multiply both sides, whatever you need to do. to have all the factorials on one side. At this point, you state your restrictions. So top is what? Bottom is what? This would be -2, right? It has to be greater than -2. It has to be greater than -1 for the bottom to work. And so the greater one, the one that would be hit sooner is that one. That's your overall. And so let's expand this. N plus 2, this is the greater expression. So n plus 2, n plus 1 factorial over n plus 1 factorial. This one is actually going to be not too bad, as you will see. You cancel out the n plus 1s. And you're left with n plus 2 is equal to 20. How many solutions am I going to have here? Just one. You know what it has to do with? The exponent of the variable. If you ever have an n cubed, it could be up to 3. I don't think that we see that. If we do, I'll make sure to prepare you. I'm pretty sure it's squared is the highest. So here you bring everything over. So n plus 2 minus 20 is equal to 0. I don't know why I did that. It's too much work. Sorry, guys. Yikes. What's easier? 20, I bring this over to the other side, minus 2. Because when you do that, you're done. Like, you don't need to use your graphing calculator or anything to solve. And is this an applicable solution? Would this work? It's greater than -1, so yes, it works. Okay. I feel like I want to say something regarding the restriction, right? It works, right? Because it follows restriction. Okay, and then just do a quick plug-in. Okay, we check on the side here. It says n plus 2. I'm going to take the original is equal to 20 times n plus 1 factorial. Right? That's the original. And you just plug that in. So that's 18 plus 2 factorial over 20 times 18 plus 1 factorial. And so this is 20 factorial is equal to 20 times 19 factorial. What's that, Mr. Erickson? What's happening now? Let's just, without even plugging this in, 20 times 19 factorial is the same thing as just saying 20 factorial, correct? So you can actually stop right there, right? Left-hand side is equal to right-hand side. You don't need to plug in and figure out what 20 factorial is, because if both sides are the same, you're done, okay? So this is how you do equations. How much time do we have? Not much. So I think, let me just flip over to the other side. Oh yeah, there's one there. Okay. That one I do have the answers to as well. So I'll give you the answers to those. So go to page 16. It's -6 and it's equal to 5. One of them works, one of them doesn't, right? This one works, this one actually doesn't work. But those are your two possible answers you're going to get there for that one. So why don't we end this way today? The homework is at the bottom there, right? 244, question 11. So you have more equations to solve. So way at the bottom here, as well as the 2 I just gave you that I didn't solve with you. So do the 2 in this booklet today. I can stop here if as long as you work, I will stop here. I won't continue what I actually wanted to do next, because I feel like you've seen enough, heard me enough. So just give these a try. and do the homework in the textbook